Hi, what we're going to look at is looking at the chain rule as it applies to integration. So just like when we were differentiating, you can see here that I've got a function within a larger function, so I'm going to be using the chain rule. So the processes have got a lot of similarities. So first of all, what I'm going to do is I'm going to integrate the whole brackets. I'm just going to ignore what's inside the brackets. So I would have originally, if that's n, when I'm integrating, it's going to be to the power of n plus 1. So I can write that function ax plus b in brackets to the power of n plus 1. And just like before when we were integrating by rule, I'm going to have to divide it by my n plus 1. So if I'm thinking about if I was differentiating this, which would get me back to there, I would multiply it by that n plus 1, reduce that by the power of n, but I'd also multiply it by the derivative of what's ever inside the brackets. So therefore, just as I've here divided it by my power, I need to also divide it by my derivative of what's ever inside the brackets. So the derivative of ax plus b is going to be a. So a times n plus 1, and then I don't forget to put my constant on at the end. So if we look at how this can work, let's say I want to integrate 4 times 5x minus 2 to the power of 3. I can also write that, this 4, I can actually take out to the front and just deal with it later. So I can also write that as 4 outside of 5x minus 2 to the power of 3. Now, if I'm integrating this, there's my 4. I'm going to integrate, I'm using the chain rule, so I'm going to ignore what's inside the brackets and integrate the entire brackets. So that's going to be 3 plus 1, so I'm going to have 5x minus 2, my whole brackets, to the power of 4. And now I need to divide it by my power. And then I also need to divide it by my derivative of what's inside the bracket. So in this case, derivative of 5x minus 2 is just going to be 5. And to add my constant on there. So 4 divided by 4 leaves me with 1. And so my answer is 5x minus 2 to the power of 4 divided by 5 plus c. So not that difficult, it's just a similar process to our chain rule when we were deriving, but instead of multiplying, we're going to divide by those two values, and instead of taking our power down 1, we take it up 1. So let's just have a look. If I've done this correctly, I can check this by differentiation. So let's say if y equals 5x minus 2 to the power of 4 divided by 5 plus c, if I derive that, I should end up with my original function. So let's have a look at our chain rule. First, we're going to derive what's the entire brackets. So I end up with 4 times 5x minus 2. 4 minus 1 is 3. Still dividing it by my 5. And I now need to multiply it by the derivative of what's inside my brackets. 5x minus 2, which is 5. And the derivative of c, remember c is just a constant, it's just going to be a number, so that's going to be 0. There, and I get left with 5x minus 2 to the power of 3, which is my original function. So I just did a quick check just to see whether I had integrated this correctly.